Okay, so I'll now discuss the bolt analysis. So the first step you do when you come to the bolt analysis is determining your PCD. And your PCD is your pitch circle diameter. And what it is, it's basically just the distance between the center of your bolts on one side of the flange and the center of the bolts on the other side of the flange. And because your flange is round, that is a diameter, basically. So you're just trying to find that distance. So let's say that this circle here on the inside is your hub diameter, right? Your hub is inside this space here. So obviously your PCD has to be greater than your hub diameter. Only thing that's unknown is the distance from the edge of your hub to the center of your bolts. Let's call that distance distance A. Now, what is that A, you might ask? And that A is up to you guys to determine. It's the distance that we provide so that the bolt can fit properly. So the bolt head has to be able to fit in this gap and not interfere with the edge of the hub. It has to be enough space for us to be able to fit a wrench or a spanner in there, so, for accessibility. When we're fitting or when we're removing this part, we have to account for some space for the person to actually get their hands in there and get the appropriate tools in there to be able to tighten and loosen the part. So that is what we leave this distance A for. So our PCD is our hub diameter plus 2 times A, because A is both this side and this side. Right? And the value of A can be completely up to you guys. Use a number that is logical, okay? You don't want to make it too big. You don't want to give a space of, say, like 10 centimeters, because then that is way too much space. And your part will then be way too big. And that's over engineering. Your factor of safety is going to be way too high. And then end of the day, it's just going to be a waste of money. So try and find a reasonable distance or a reasonable value for A. Generally, I would suggest using anywhere between 30 and 50 millimeters, that is. Of course, it can be less than that or greater than that. It's completely up to you. You can even research it. Some manufacturers for coupled flanges, they give those dimensions. So you might even be able to use some of their dimensions or some of their distances to then figure out what value of A you want to use. But it's completely up to you guys. It could be even less than 30. So once you have your PCD, you are then going to be able to do your calculations to find your torque, to find your force, and then to find your stress. So once you have your PCD, you can then identify what type of force is being acting on our bolts. So what type of force do you think is acting on our bolts? This part is twisting in this direction with some torque, and it's creating sort of a shearing action, a twisting, shearing action. So this is a shear force. If we're looking at shear force, then we'll be looking at shear stress. Shear force is calculated using our torque. So torque is equal to the shear force multiplied by the distance. This distance is the center of the shaft to the center of the bolts, which is PCD divided by 2. All right. So that's why we need to find our PCD first. Once you have our PCD, we can find our distance, use it to solve for our force. So we know our shear force. Now the area. This area is the total area, or the total shearing area. And this area is the cross-section of each bolt multiplied by the number of bolts that you have to restrain. Area is the area of the bolts, and the bolts all have a circular cross-section. So pi d squared over 4, or pi r squared, multiplied by the number of bolts. Our shear stress, we take this from information given to us in the question. Now, in the question on the first page, it gives a bit of information about the types of bolts that we have to use in our assignment. But you'll notice that there is no mention of the shear yield strength of the bolts. It's only the tensile yield strength given to us. And we won't be using that because we are interested in the shear, not the tensile. However, if you read the information for the bolts, and in the second paragraph down here, it says the allowable shear strength of the steel fastener is about 0.66 times that of the tensile yield strength. 0.66 times that of the tensile yield strength. So our resulting shear stress is 0.66 times our tensile yield stress, which is 0.66 times 240, which is 158.4 megapascals. This is the value that we'll use in this equation. So if you plug these all in and write it again, we have shear stress is equal to shear force divided by pi d squared over 4 times number of bolts. Now at this stage, you have two different ways that you can solve. First method, you could say the number of bolts that you want to use. So you could state the number of bolts and solve for the diameter. Or you could state the diameter and solve for the number of bolts. Right, there's two different ways you can go about it. You could either say, okay, I want to use 5 bolts, but I don't know the size of each bolt, and then make D the subject of the formula and solve. Or you can say, I want to use bolts that are 16 millimeters in diameter, but I don't know how many of those I need to use, and make B the subject of the formula. So it's really up to you. Now let's say, for example, I use the first assumption and I say that I want to use 4 bolts. And I need to solve for D. And once I've solved for D, I find that my diameter is 13 millimeters. Using this information, I will then go back to my data sheet on the types of bolts and the sizes of the bolts and look for 13. So M13. M just stands for metric. So I will go and I don't see any M13. M13 falls in between M12 and M16 in this data sheet of the available bolt sizes. So obviously I can't go for 12 because if I go for 12, then my bolts will fail, they'll shear. So I will choose M16. So D is equal to 13. So my actual bolt diameter has to be greater than 13. So it'll be equal to 16 millimeters. And then I will close my bolt analysis off with the statement. I will use M16 by 4 at a PCD of whatever my PCD was. Let's say it was 180 millimeters. And that's how you would close off your bolt analysis. Does that help answer your question? Okay, cool. So we're running a bit short on time, guys. So I'm gonna have to end the session soon. If you could just leave your name and ID number in the chat, and if you're not part of this tutorial session, you're not signed up for the 2 to 3 on Friday tutorial session, but you're from another session, please also include your actual ID, your actual tutorial session that you're part of, so that it's easier for us to track your attendance. Just a quick thing, is the project going well? Hopefully you guys are wrapping up your detailed drawings now and you're working on your uh, presentation slides. Hopefully, if not, then not to worry, you still have next week to do that. I believe you also have a short test next week. I'm not sure short test, if it's theory or if it's going to be your lab short test. I'm not quite sure. But you have a short test next week as well. All right, any questions before I end the session? Okay, well, thank you very much for your time. Thank you for attending, and I'll see you all next week. So the recording I will upload on YouTube once the session's finished. Are you part of the 2 to 3 session? If you are, I'll send the link to the Viber group and you can access it from there. Just leave your name and ID number so that I can update your attendance. Okay, sir. Thank you, Akshay.